Trying to be quick. Have lunch, I guess. So this is an update about the work that we've been doing in Linaro for CPU cluster idling. Basic stuff. Good. Okay. So before I'm going into the stuff I want to just talk about, I'm going to give you a very quick overview of how the how the stuff works that we've been posting this. So the situation is obviously becoming more and more complex, and it's already complex enough, and it's going to be continuously more complex. So we have different domains and caches that we want to manage in full manner. And there is clusters of CPUs and all this kind of stuff. And we have seen that the CPU idle that is managing CPUs today, that's doing a good job from idling the CPUs in that sense. But dealing with all the and share the devices within this kind of cluster, that's a different thing. Dealing with that. So yeah, this is the latest version that we posted on this series, and I've been using the Dragon board for NC for using for doing the validation, and I haven't really done some real power measurements on that board yet. That's the next step I will look into. And so I've been mostly using F-trace and other statistics to see what's going on, more or less. And we're also going to look into the Dragon board 820 for test. So this is an overview of how it works. So and the new process here is things that goes on in the CPM layer, where we have added calls for dealing with runtime PM, which is done in the other path. So you're using runtime PM to actually control PM domain on top of the CPU device, notifying it needs to stay on or. And the stuff that we have been changing in YMPD is more or less just make it aware of that it can contain CPU devices as well. There's a couple of constraints that we need to take care of, and we also want to know a little bit about what CPUs that we need. So checking that for the devices we're using a CPU mask, where we give the information more or less. And the other new part is that we have added a new governor in the MPD layer. Earlier, the governor more or less just taking care of device PM latency constraints when devices and domains are being powered off. Now we want to take care of residency for idle states as well. So that's the new thing that we've been adding. And on top of that, the PCI PM domain. The PCI is the ARM64 specific interface for dealing with. No, it's not ARM64 anymore, but that was.
Plus justification.
Yeah, exactly. So that's the talk specific or architecture specific part that is not generic in the solution. So a quick overview of how it works. So the PCI driver detects this PCIO initiated mode, which is the constraint for actually using this solution for PCI at least. And when it comes to the next step, it uses GNPD to initialize all these topologies using this infrastructure in GNPD. And when that is done, and all things have been verified to work, it enables the service initiated mode in the PCI firmware. And as a first step, that's when the CPU idle driver gets instantiated and passing of the idle states being done, and then it calls, it ends up calling the backend driver of the CPU idle, making CPU idle driver, and that is when the attaching of these CPU devices happens to the domains, and then everything starts to play off of that.
How does this work in extent-like scenarios?
From the PCI firmware's creation point of view?
Yes, I can't remember, but I remember we had rainfalls with this and solid state.
So what we do,
There's a mode switching API.
so what we do to cover those cases is that during the PCI initialization, firmware initialization, driver for firmware initialization, we always set it to the default mode, which is the pattern coordinate mode.
Yeah, the pattern coordinate is only in pattern coordinate. Is it even close? I guess yeah, exactly. Guarantee that.
Okay, so this is the overview of what's happening when we're entering idle and leaving idle. So the PM runtime calls in CPU PM label gets invoked to bump or decrease reference count on the device. And when that happens, all the infrastructure in EMPD gets called. So the runtime PM callbacks gets called, and then if the domain can get the power off, those callbacks get called. And then in the if it's the last CPU that gets power off, this last man standing algorithm is also covered inside the EMPD because that sees that the master domain, the cluster, is also capable of being powered off. So that's what goes on when this PM runtime gets it. And finally, we will end up in this PCI PM domain part, which is so specific parts of the PCI. Of the PCI is a specific part that gets called when the domain gets powered on. And in that scenario, there is a pro-CPU variable inside the PCI driver that stores the selected idle state that has been selected by this new government.
There is a reason why PM runtime was chosen CPU PM enter, because that doesn't get called for retention state.
We don't want it to be called for WPI, for example.
No, retention states, yeah, you have.
You can have retention.
Yeah, that's true. So it's the reason, the reason why we picked that place is we wanted to make it generic. So that's why it's in there. Potentially, we could do it in the ARM idle driver instead. So we wanted to pick a place that was generic, so it could be useful for other scenarios as well. That's why.
By the way, this is one of the reasons why injecting idle may be effective sometimes.
Because
The other license.
Yeah. There could be cases where you have other domains. Yeah, absolutely. Yeah, so this is the overview of how it works. And for dealing with HUT, like the PCI driver calls the interface of the MPD for detaching the device temporarily when it gets online again, reattach the device. Otherwise, the infrastructure in EMPD would have kept the domain being powered because the CPU device looks like it's being used. That's how we deal with that scenario. Okay. I'm waiting for lunch now. So there's a couple of things that I wanted to discuss and limitations that I've seen, and there's probably some more that you can help me to add to this list. But we have added a new function in the for no hertz part, and that is to find out when the next wake up is going to happen for a CPU. And this is a very simplistic approach, which we've taken to start with. And so we are using the CPU, the clock event device for the big CPU, and fetching the next event of that. And we use that to calculate to compute the duration until when the next to compute the duration for the sleep time to compare for the residents.
You call it when entering the state, right?
We call it when the cluster is about, when we know that all, in the last man standard algorithm for all the CPUs in the cluster.
Yeah,
then
so
we call
that's when you enter the state.
Yes, yes.
Yeah, okay.
So, but obviously there is more reason why you can wake up. Why a CPU can wake up.
Oh,
So
yeah,
actually, so this is a very simplistic approach.
That's the timing.
It's just doubles the time. So, and then one other thing that is a bit problematic is that this PM1 can get and put calls is done now explicitly unless it's W5. And if you have more CPU idle states, the information about what idle state that CPU has been, what state the CPU has been selected for is not known to the NPD when it decides on the cluster level. So there is some mismatch here in knowledge. For this 410C board, H20 is not a problem, but you might have to look into this. So the other open topics that is, I think we need to think about a little bit going forward with this is that the new governor in NPD, I mean, is obviously completely different what the regular CPU idle governors are doing, and there is some heuristics in there that we might want to reuse, or I don't know. I'm just thinking that we should not take all of this kind of semantics. It should make sense to have a common way of dealing with this. The problem is though that this in the NP part is only today. It's only thinking about the cluster level, so it's a bit different compared to the idle governance. So then there's some thinking about that, and overall, we have seen problems with the CPU idle governance, and that it may not always predict perfectly. So a while ago, when Daniel was working with this IQ prediction, that should be a way of improving the situation generally. I don't know if you have any comments about the governors or thinking about that.
So I look at questions on the street. I have some, but
Yeah.
So, generally speaking, I agree that there should be some collaboration between the governor and the so that they don't pay it.
The other part is also the new idle loop we have been doing, stopping and not stopping the tick. There's no such thing that we take care of from.
Yeah, well, that should work.
It should work as long as the idle governor and the idle driver does it works correctly. But if it says that, I mean, it depends. My point is that it's two different infrastructure that decides differently.
Yeah. So
Yeah.
that was my point.
Yeah.
They need to agree on things
Yes.
instead of having.
So moving on, that's more like a generic device PM issue. These devices that now are sharing this cluster can just be put in. They can just be modeled in the topology, and it's quite common for at least for legacy platforms, that there is more devices sharing in the domain or the voltage domain of the CPUs, and some of those devices, when they are in use, they need to prevent the cluster from going down, and that can be easily covered with this solution. It's just by hooking them up in the corresponding domain. One thing that is a bit tricky is that we have devices that are not really suitable to deploy runtime PM support, and that is like interconnects and those kind of stuff. But still, when the cluster goes down, brings being powered up, sometimes these kind of devices needs to save register context and restore register context. So somehow we need to interact with this kind of system device. What?
You mean like coherency?
Yeah.
A coherency?
There are definitely platforms that do that.
That's actually non-compliant perspective.
That sounds wrong.
And it's frankly mistake.
Maybe the problem is bigger on legacy than newer. But I've been thinking about how to actually deal with these devices, because there's no like get and quit for this. You need to manage them somehow.
So I would expect the firmware to manage them for the PSCI.
That's actually required by this.
Okay. Maybe for PSI this is not a big problem anymore.
I mean, if you do find platforms like that, then where the claim aspect is fine, but it's still required to manage anything from the net.
Okay, so perhaps the regular devices is good enough, like 4 cycles. Okay, so CPU PM nodes fires. I know we've been discussing a little bit about them earlier. I guess we're trying to replace something, and I just want to double check that this is still viable goal, or you think about that? It's not that much. Especially there is this CPU PM cluster notifiers. And it's a bit fairly useful. I have some idea that we might be able to, in the long run at least, move away from this. I guess that makes sense. Do you think? What? You don't care?
Well, they are using ARM. So I satisfy them personally.
Okay, and the final part, I think we can skip that part.
Do you mean the video stuff?
Well, the coupled idle state where you have to put or coordinate idle between.
Well, so the difference between platform coordinated and OS initiated. OS initiated would be OS in charge of doing something. Whereas the platform coordinated, which is what the default implementation is, effectively the firmware does. Essentially very, very similar.
Right.
And you just
And
have
I would hope that we see more of that.
And to be honest, yes, so I've always been pushing platform coordinated, but OS initiated has, in theory, the promise to remove certain SMP fields and in some conditions. Particularly in those performance scenarios, could be more efficient. However, no one has ever given us any numbers.
Well, the problem is that it's SOC vendors do what they want, and
Exactly, and so and
What's
so
some kind of SMP for wafer?
So the sort of scenario is, let's describe sex industries have a dual tier system, like with a system. So you could have a C-state propagating before, and then a C-state for the packet state, right, for the overall system. Right? When one core goes parallel, you go for platform coordinated, really what that core is, there is just expressing the value. It's saying this core can go in parallel state, no default, right? When the second core goes into the parallel state, if that core already knew that there is no PM core style constraints, it could actually say, you know what, just try that and hold on. go straight. But because they are votes, what needs to happen is you need to get the first vote to re-vote. S&P kick it. It wakes up and then it goes, oh, there's no constraints now, and then everybody votes for the
That is promotion, yeah, we don't do that.
Oh, so it doesn't work.
Okay.
The code says the deepest state recorded. And then it is recorded. And then the other record asks for something, so that's deeper.
No, well, that's what I mean. So first call, let's say that you have some constraint active. First call says, I only want to go to the those constraints before validating. I don't want to go deeper than that because there's a constraint right now.
Yeah.
Right? And that constraint lives.
Okay.
Right? At the moment, and in fact, I haven't lived this for a while because but I remember looking at the across the time, and in there, when the constraint changed, there wasn't a simple. I don't know whether that's been moved or not, but it certainly wasn't.
No,
Right? And so, if a PM cross constraint changed, you would rank everybody up so it can revote. But instead, OSI basically says, if the last man in a group says it wants a particular state, and the hardware is in a state that's compliant with that state, just do it. Don't treat the things don't treat them in natural order.
Yeah, okay.
Right? And so in theory, it saves you from doing that. The thing is,
There's
I
also,
know we internally ran a few Android use cases, and S&P gives actually been involved.
so the,
And so,
those constraints are the other
but you don't know. I mean, maybe it's right. And maybe if you go to like
the use
96
case.
core systems, then
It's
maybe
not
it
the,
becomes more
it's not
of
the
a
only
big
use
deal.
case. There are other use cases. With coordinated mode, when you decide to form collapse the cluster,
Mhm.
it's based on vote that have been done quite a long time ago.
exactly.
Yeah.
I was
And in
coming to
fact,
that.
things may have changed so that you know that one of the SKU is able to wake up quite early. So you will probably form collapse the cluster, even if one of the SKU will wake up in 10 microseconds. With the OS initiative mode, the decision is done when we want to form collapse. So you are up-to-date information, which is
Yeah,
not
yeah.
possible with
And that's why we put it in the spec.
yeah.
So we were open. But what I'm saying is, I need to see a comparison.
So
It takes the platform, real use cases, but
I
the
guess
vendor that brings to us
Honestly,
has
this
not
is,
implemented both, has actually.
if
It's
you
also
ask
actually
me,
not spent
Rafael, you just told us that you're having a governor in your firm.
yeah,
You have that for a reason, right?
well, so that's more complicated.
Yes.
But
Okay.
anyway, if you ask me, then this is the extraordinary case. It doesn't happen very often anyway, and the cost of it in the code is significant. So I'm not sure if it is worth.
That's one.
But
And I'm sure that there's certain use cases.
It would be terrific if we could have like a platform that we can actually try to go.
Actually, what you're required to do for the
So-
specification, that's not what happens.
No, obviously not to do, yeah. So, but that's in our, I mean, we would like to do that as well. That requires us to change the on-process firmware in the upstream version of it. And that's in our plans, but it's things take time to do everything. So at the moment, we're focusing on trying this out on existing platforms.
And it's from there that someone can grab it easily because the last time I tried, it was very difficult to get the firmware. So it's very hard, like if you add these codes and you can't get that to the firmware, it's very difficult to maintain it. And if it's only a couple of vendors who are producing it and they don't care mainline, adding these complexities might not be worth.
The complexity is not, I mean, if you look at the changes in the patch that you will see, it's very simple code, and it does not affect the platform coordinator mode in any bad way at all. So, complexity is.
As you say, by the way, that because we have OSI, we also put OSI in place. So take that for
Yeah.
else that we need to look at.
Okay.
Because if there is a case, S&P gigs are going to be a lot more expensive than 196.
Oh, yes, obviously, I think this is not ending the enterprise market at all. This is
At the
probably,
moment, yeah. That's my point.
it might,
At the moment,
yeah,
if it actually does prove,
Yes.
this is what I really want to know, because I'm not being skeptical
Yeah.
about it, I'm just saying, I just want to understand it.
yes,
And so if it turns out that they are really expensive, have very high core cap
Yeah.
systems, and really big SMP things, then, yeah, it'd be nice to know, and then
Yeah.
we can need to discuss
yes,
perspective of both stuff.
yeah. All right. Anything else? Thanks for listening.
Yep.